So, thinking about cooking, I realized something interesting. So this is a breakdown of the US units, customary system of units, for liquid volume. Now, note that for the most part, the dry volume names and ratios for units are the same, but they are different volumes slightly. But those are used almost exclusively for shit like fruits, like apples and grapes and whatever the hell. They're basically not used. So this is deceiving. Dry volume, liquid volume, because this is actually what you also measure things like flour, like your dry ingredients when you're cooking and baking, are measured with liquid volume. So maybe fluid volume would be a better term. I don't know. Anyway, so 3 teaspoons per tablespoon, 2 tablespoons per ounce, and that's a fluid ounce, not the mass. All right, so 16 mass ounces go into a pound. That's a different thing. But it's basically comparable to how a gram and a cc, or a gram and a milliliter, cc being the same thing as a milliliter, a gram and a milliliter are not really the same thing. It depends on the material in metric, right? So this being different from the mass ounce doesn't fucking matter, because there's going to be a substance where it is actually the same. 4 fluid ounces give you 1 gill. This should be gill. 2 gills give you 1 cup. 2 cups give you a pint. 2 pints give you a quart, and 4 quarts give you a gallon. Hey, look at that. Quart. Quarter. It's the same fucking word. That's why there's 4 of them. But then if we look at this, if we add these up and we average them out over how many there are, this acts as a cumulative base 2.7142857142857, etc. system. As the right-hand values sum to 19, and there are 7 of them, or 2 and 5 sevenths. 2 and 5 sevenths is almost identical to E. And if E is the most efficient possible number base, then this is quite remarkable. Because really the system, for the most part, actually ends at the gallon. So this is actually, and the subdivision below this is ridiculously tiny. Right? It's like 60 or 80 of the next thing goes into this. So nobody really uses that. Right? Like, what is it, drams and drops or something like that? Nobody uses that shit. But these, perhaps excluding the gill, these are used regularly in cooking. You regularly hear about teaspoons and tablespoons and fluid ounces and cups and pints and quarts and gallons. So if this is the subdivision of a gallon that is naturally used, and it approximates very, very accurately a base E number system, and base E is the most efficient possible number base, that's some shit right there. And it's also fascinating that fans of metric deride it simply because they're incapable of counting to 3 or 4. Right? Right. Ask somebody who uses metric all the time to find 1/3 of a meter, and they will tell you it's 333 millimeters, which is wrong. You still need that last third of a millimeter. In metric units, you cannot natively get that. And they don't understand what you're saying. So like, no, it's 333 millimeters. No, if you multiply that by 3, you don't get a meter. You're short 1 millimeter of a meter. 999 millimeters is not a meter. It just isn't. Right? And that's a big enough difference that you can actually fucking see it. Right? So over here I have this Stack Exchange pulled up, right, where somebody was asking, you know, how this makes any sense. Like, what was the original question? I remember reading somewhere the base E is the most efficient base. Yada yada. Apparently, the maximum efficiency occurs at base E. How is this possible? Can irrational bases even exist? How is efficiency of a base numerically calculated? So down here, this is a pretty good answer, I thought. So let's specify the sources from Wikipedia. It's actually Hayes 2001 is the real source here. Base E is most economical choice of radix vita greater than 1, according to Hayes 2001, where the radix economy is measured as the product of the radix and the length of the string of symbols needed to express a given range of values. Which actually, that's a pretty reasonable way to look at that. So then there's more that he doesn't feel like reading. I understand that. I'm abbreviating even these little paragraphs. The matter boils down to the representation of the number n in base vita, integer or not. And this takes the approximation of log n on log vita digits. If your idea of economy is the product of this length with vita, then of course you're going to minimize vita on log vita and find the minimum is at vita is e. Yada yada. Okay, the reason that you would do this, right? So the length of your string is going to be log vita. Well, log n on log vita, whatever your number is. The reason you're multiplying it by vita is because that's how many options you have for each digit. So that's the reason that you're doing that. Yeah. So there is some real truth in this economy being at vita being e. So this is fucking amazing. That when we average this out, we actually have in practical usage an established folk tradition, effectively, in practical usage that comes wildly close to approximating this. This is amazing. 99, or yeah, well, let's see. If we were to change this to a percent, which I didn't properly do. 99.85299, and then the next digit is like 117 something. Percent of E. That's ridiculously close to E. This is using integers. If we just cycled through this, right? So if we had our number system that it went like this, and then repeated, this effectively acts like base E. So this is our subunit of 7, right? There's 4 of those. There's 3 next to it. There you go. So boom, 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 boom. Right? This is exceptionally close to being an actual number system that uses integers that is base E. So much like my number system, which operates like this. Sometimes I can type. And the reason that I chose that is because it is it's a very large antiprime. Here, with this number base, you're not going to get as many nice prime factors, right? So here, like I'm choosing 52 because you'll get 13, or wait, no, this should be 77. Wherever you see 70s, there should be 77. Here, let's just do this correctly. There you go. Just kill that back about there. Alright, so 52 catches a 13, 77 catches 7 and 11, 60 catches 5, 4, 3, 2, and 6. 8 is captured by the pair of 60s. 9 is also captured by the pair of 60s. 10 is in there because of 2 and 5. 11 is in the 77. 12 is in there. 13 is in here. 14 is between these because of the 7 and the 2. Or between these because of 7 and the 2. 15 is in here. 16 is actually between, let's do it this way. 16 is captured there. Or wait. No, you don't need that. 16 is captured here or here. Yeah, that'll work. Because 4 times 4, that'll work. 15, 16. So 17 is the first one that we miss. So that's why I like this one personally. But it's interesting that this efficiency argument actually brings us to something that is exceptionally close to the United States customary system of units for liquid volume. I think that's something that maybe people who are just mindlessly pushing metric should consider. Maybe you don't know what the fuck you're talking about. Maybe there is wisdom in these old ways that you want to crush because you're stupid. And you can only count by 2s and 5s because you're a dumb monkey. Just a thought.